Hi grade 12, welcome to my channel. Let us share some insights into solving this problem. It was one of the prelim exam question papers on the 3D diagram for maths paper 2. So it looks like some private school or perhaps IEB. It looks typical of IEB, exam question papers. So this was shared to me by a friend to me and a colleague essentially. So I think this was indeed an interesting question to have a look at and perhaps share some insights as to how best to approach questions of this nature. Right. Yes, we often have mapped out sometimes, which structure is best to start with and all those kind of things, but at times it just gets a bit overwhelming. So yes, in general, we need to remember the structure of how things work, but there are some surprises, okay? So sometimes the rules can change for a specific question or a particular question. Right, so let's have a look. We're told here that in the diagram below, a car is traveling from C to D. So we can see that is from D. It's traveling in that direction to a destination at point C. Okay, no problem. And we're told this is a straight road to suggest that DC is a straight line. Okay, BC and D are in the same horizontal plane. So that is what we see, guys. So I often prefer to shade. So essentially, folks, once we shade it, we can see nicely that these are points just on the same horizontal plane. All right, let's read on. So what are we told? AB is the edge of a vertical building, of height 108 meters. So if this is vertical to the horizontal, so this means we have 90 degrees there. And the same is true for that part. Okay. Right. Okay, this thing is refusing to connect to the thingies. All right. So essentially, guys, the diagram, when it is not decorated, essentially the student needs to decorate it. So this is a height of 108 meters. Right. Now the angles of elevation of A from C, right, and D respectively are 28 degrees and 47. So these are already indicated, so we can see them nicely. Right, BDC is 35 degrees. Again, this is indicated, nice and easy. So folks, yes, the diagram is as we see it. So what is the story right now? The story for us is to calculate the length of the road CD, correct to the nearest meter. Okay, very important. Of course, guys, there's a space dedicated for that here, but I mean, to avoid this up and down business, I'm just going to simply answer on my canvas. All right. So there is question 10. And essentially we've got A. Now A, folks, how are we going to deal with this CD? We can see that CD is a part of this shaded triangle. But we'll notice that technically this height AB is common to two triangles, ABD and ABC. Okay, we've got those angles of inclination, we've got the opposite side. So it means we can work out the adjacent sides in those triangles, right? Right. So now what we need to do is to say, first and foremost, what I want is to state that I'm working in triangle, essentially BCD. That's our main triangle. But we're going to use these other triangles, this one, to get to business, as well as this one. Okay, that is what we're going to do. Right, so what do we need, guys? We need BC in a way. So we've got the angle, we've got the opposite side, we're looking for the adjacent that spells out the tangent. So we can just easily say tan of 28 degrees is going to be equal to the opposite side, which is essentially 108 divided by the adjacent side, which is BC. So this implies that our BC is going to be equal to 108 divided by 28 degrees. So therefore BC is going to give us something. So 108 divided by the tangent of 28 degrees. So this gives us, of course guys, these are intermediate answers, so we're not going to round off too soon. So this is going to be 203, let's just keep it as best as we can, 1185 meters. Okay, so that is the side BC. We also know that the tangent of 47 degrees should give us essentially 108, the opposite side, over the adjacent side, which is BD. So this implies that our BD is going to be 108 divided by the tangent of 47 degrees. So therefore BD comes out as C108 divided by the tangent of 47. So this gives us 100,7116 meters, just to keep as many decimals as possible. Okay, of course you can take all the decimals you see on the calculator. There's nothing really bad about that. All that matters is to getting the job done. Now folks, we can clearly see that we've got now this side as well as this side, and we can see that in this triangle, that side CB is opposite the angle 35 degrees, whereas the side BD is opposite that side. Sorry, that angle. But the problem is that we only have one angle. So what is best to do? Cosine rule. We've got that side. We want this side. We have that side. We've got the angle. So the cosine rule is going to take us home here. So we can say then, we know that essentially the side now that is going to be square is going to be BC squared. It's going to be equal to CD squared plus BD squared minus 2 times CD times BD times the cos of angle BDC. Right, so that's the cosine rule in that same triangle. Okay, it's one of those essay type questions. Right, so let's substitute. What did we get BC to be? We saw that it's 203,1185. We square equals CD, that's what we are looking for, plus BD, we found out it's 100,7116, all squared minus 2 into essentially CD times this 100,7116 times the cosine of that angle 35 degrees. All right, so moving on nicely guys, let's just keep it moving. So obviously folks, our interest is to get our CD, and as we can see, this is going to be a quadratic. Okay, whether we like it or not, we are not going to avoid a quadratic equation here. So this question is packed, my goodness. Right, so let's go on guys. We know that CD squared is going to stay there, CD squared Then we're going to have minus. Let's evaluate what we get over there. So we've got 2 into 100,7116 times the cosine of 35. Okay, now the key part here, guys, is to make sure the substitutions are good. So what we get here is 164,9962, right? Right. Now this is going to be CD as well, because this is evaluating this part. Okay, good. And we then transpose that 203 squared. So this is 203,1185 all squared. So what do we get? So we're going to get some 4,257. In fact, let's start with this one, the 100 squared. So this is the 100,7116 all squared. Then we're going to subtract the 203 so that we can have it nice and easy. 203,1185 squared. Okay, so what we get here is a minus 31,114,2987. Okay, just to keep as many decimals. And of course, this is going to be equal to 0. So we can see we've got ourselves a nice quadratic equation. So this implies that CD is going to be equal to, obviously, guys, before we substitute, I think it helps to write, I think it helps to write the formula. So we can say, well, we understand that x in general is going to be equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So this implies that CD is going to be equal to minus into 164,99. Actually, it's negative, so it's going to be minus into minus 164,9962 plus or minus that BSH 8 there, so this is minus 164,9962 squared minus 4 into 1 into minus 31114,2987. I knew that was coming. Flirting with the limits. Okay, let's write it properly now. This is just going to be 2987. Okay, so all of that over 2 into 1. So obviously, guys, CD should be a positive answer. Right, it's quite a hectic situation, but we can handle it. So this is minus 164,9962 plus the square root minus 164,9962. Please, guys, be very meticulous at this point, because a small little digit error here will lead to an incorrect answer. So everything must be there. Okay. So 2987. Okay. I think so far everything is going okay. So the first answer is nicely positive, so I can accept that this is 7 meters. Remember, we're told to round off to the nearest meter. So essentially, this one is as good as what we see there. Obviously, the other answer would have been negative, so that would not count. Okay, let me check it before I say things that may not be true. But let me just tell you something, guys. The reason I know it's going to be negative, I'm looking at my quadratic, okay? I'm looking at the shape. And this shape is telling me that this is a quadratic that has a minimum value at the turning point. Right, okay, let me choose a pen. So this is going to be a quadratic like this on the Cartesian plane. Obviously, what do I know? It has a negative y-intercept. So my graph is doing things like that. Excuse me, guys. Yeah, my throat always does this when I'm doing videos. Don't know why. Is it talking too much? My throat gets dry. I don't know. Am I nervous? Or it's just the gadgets? Maybe, sometimes these electronic gadgets, I noticed they have an influence on the nervous system. So guys, it's either we have it like so, or perhaps it's leaning. So it's either we have it like this, where the axis of symmetry is to the right, or that way. But how do we decide? We look at the middle term. So, excuse me again, guys. So the middle term is negative. So remember, it's going to be minus b over 2a. So this thing becomes positive. So we look here. If this is positive and the denominator is positive, so this whole thing is positive. So it means our axis of symmetry is to the right. So our graph looks stuff like this, essentially. Okay? So this is why I know there's going to be a negative root and a positive root. But remember, this is a real life situation. So we're going to choose a positive root. So please remember these things, guys. I cannot overly emphasize the knowledge of just maths in general, algebra, functions, whatever. It helps to also study these things so that you know what to expect or to anticipate. At this stage, I don't really see the point of checking the other one. But again, as a student, sometimes you don't know these things because you don't think about them this way. Perhaps do have a look at these things as closely as possible. If you change the sign there, we get a minus 112, and that we cannot accept. Okay, great stuff. So these are some of the things that one can use to assist themselves to get the greatest of the picture about what we have. Good stuff, guys. So that was just me thinking out loud. So in essence, guys, I'm looking at 108. So this doesn't look too bad. I mean, if you can take that line and put it across here, you would see that, of course, this is not drawn to scale, but proportionately, that should not be outrageous an answer. Sometimes with these questions, it's a matter of saying, is the answer outrageous or is it reasonable? If not, then you may have to look at it again and see if there's a mistake in the approach or something. As you can see, this question is packed, guys. Look at this mark allocation, 8 marks, because it shows that there's an integration of serious issues here. Trigonometry in terms of, the basic trig ratios, and then we went on to the triangle rules, and then from there we ended up with the quadratic. So essentially, it is worthy of those marks. Okay, if we were just going to, mark these, I think the size of BC, the size of BD is key. Setting up the cosine rule in this specific structure, as much as, it's a rule, but to be specific about the diagram is quite a skillful way to think about it that way. And then the substitutions, of course, in general. So we've got 1, 2, 3, 4. And essentially, I think the quadratic is key. Then the substitutions into the quadratic formula and selecting the right answer is key. So let's see. 1, 2, 3, 4, 5, 6, 7. And of course, the 8th mark, folks, can be anywhere. It can be anywhere. So I mean, for using the tangents in those separate triangles, we can mark one of them and say the other one is perhaps considered within. So the extra mark is truly just for the effort, I guess. Alright guys, so that is how that question is sorted. As you can see, it fills up an entire page. Alright, no problem. Let's get to the next question. The next question says, determine the range of angles of elevation from the car to, you see, the reference point is the car, to the top of the building as the car moves from D to C. Now folks, we know that with the word range, we're talking about minimum going to maximum. That's it. So technically, we need to decide about those issues. Which one is going to be minimum and which one is going to be maximum. Right. If we look at this diagram, we will see that, folks, technically, this length, since we're dealing with the tangent, you see the tangent, the opposite side is the same, it's fixed, but what keeps changing is the adjacent side as well as the hypotenuse side. As we can see, this distance is certainly greater than the direct distance, like that, and as we move further away, the distance again keeps on increasing. So we can clearly see that at the starting point, it was 47 degrees. That is the car when it is at point D. That's 47. When it is at point C, is 28. Obviously, this is when it completes its, what you call, travel. So technically, 28 should be the smallest we can get here, because obviously 47 is bigger, 28 is the smallest. Now we need to find the greatest angle here. When will we have the greatest, basically, what do you call this thing? When will we have the greatest, oh my God, the greatest angle of elevation? Now remember, we need to look at this diagram differently. But if I can tell you for free, this will happen when the adjacent is the smallest distance, isn't it? Which is this one right over here. When the adjacent is the smallest distance, this is when this point is directly opposite or in line with B and the height of that building. So this is when this angle here, essentially B to this point, maybe we can call it point E for just understanding purposes. We will see that the hypotenuse is always bigger, and then it keeps on getting smaller up until it becomes that size. From here on, it's going to keep increasing up until it is equal to the other one when we've got an isosceles triangle like that, where we would say perhaps this side is equal to that side. And as you can see, these distances keep on increasing. And remember, what am I saying? The angle of elevation, if we think of it as the tangent of theta, it's going to be the opposite, which is the constant. It's not changing, it's 108 over the adjacent side. Now the adjacent side is what we are changing, right? So we can clearly see that if this guy increases, the ratio decreases. And if the ratio decreases, theta also decreases, right? Take example, say 10 of 1. See what that is. 10 of 1 is basically a 0,02, for example. And if we increase the angle to 2, you will see that as the angle increases, the value of theta also, the value of tan theta increases, meaning this increases. But now when we decrease this ratio, what happens to theta? It also decreases, isn't it? So wait, what am I saying? No. When we increase the adjacent, this ratio decreases as a whole. When it decreases as a whole, theta also decreases. But when this ratio, the adjacent side becomes the shortest, this one approaches maximum. In fact, at the shortest adjacent, this whole thing is going to be a maximum when the adjacent is the shortest. And it is going to be the shortest right in a situation like this. Okay? When that line from B to E is exactly perpendicular to the horizontal, as is the case with the height of the building. Right, or thought of differently, let me do this. I don't know if it's gonna work, but it may. Let me try. But sometimes when you just do the triangle straight up, it becomes a bit uncomfortable, but I'm gonna do something about it so that we get it right. So let's take this triangle. Right, I don't know if it's gonna do it. Yeah, it did it. Okay, I just want to produce the sides that I want so that I can be able to crop them. Yeah, it's not gonna really do me any good, is it? Okay, but we can approximate certain things. Let's take it. This is the horizontal one. Take this one. Just want to show you guys something. Take this one. Okay. I need that size to be exactly the same. Of course, guys, I increased this, so something is gonna be a bit bigger than it's supposed to be, but anyway, we can adjust for that. Of course, guys, the reason for me to take longer is because I want to take you guys step by step through this process, because these are the things you need to think about on the fly. Okay, you're not gonna get any form of preparation for this, so you've got to do it on the fly, folks. Okay, guys, so let's do it. Right, folks, so perhaps let's just put it aside for a second and take this guy away. So guys, it helps to analyze these expressions, because if this is not done properly, the whole thing becomes a disaster. Okay, so this is what we had, right? But now what I'm gonna do, I'm gonna rotate it. First, let me shrink it so that we can work with it nicely, and then we're gonna do this and rotate it a bit so that we can look at it from the side. But it didn't really come out the way I want, actually. It didn't. Okay, so if we rotate this, guys, let me just try to show you something. You see that angle? Still the same as this angle of 47 degrees. Right? But now we are looking at this situation when this line is exactly in line with that line, so to speak, such that this angle between the horizontal like that and that line from that corner of B is exactly 90 degrees. But this is going to defeat what I'm trying to do, so it's not going to work. Actually, I should have just forgot about trying to be as it is presented, but I just want to show it in a different light so that when I solve, it's easy to see what I'm doing. Okay, right. So what I'm trying to get to, guys, is to say, if we were to look at this sort of in this manner, you know, right, so and say this was our original height, so to speak, but now this is sort of like sitting in this manner. I'm gonna create a bit of an angle, but remember this angle is supposed to be, okay, maybe let me do it differently and say, okay, let's do it this way. Excuse me, guys, for all of this trouble, but sometimes it helps to think about these things. Okay, let's say this is our vertical line, and this is now this situation right here when we are looking at it, but now looking at it from the side, so to speak. So we would still have a line going like that, and maybe let's make it even more exaggerated somewhat, perhaps angulate it a bit. Ach man, wena. Ngicela wena man. All right. So essentially, guys, we do this. This is what we want to do. Okay. Right. So if we look at this is still that same angle between A, B, and D. So this one is still 47 degrees. Nothing changes. But I want us to be able to look at this triangle nicely. Okay? So when this, but now I'm going to show that angle to this side, that this one is supposed to be 90 degrees on the floor. But this will also happen when this line is itself perpendicular to the horizontal somewhat, the slant height. Okay? So think about those things, guys. And then, of course, we would have that line going to that point. So essentially, this angle is still the same, 28 degrees, you see, at C. But now what we want to look at is when we get this maximum is going to happen in this triangle. It's going to occur in this triangle, this slanted triangle. But what are we going to be able to use to solve this problem? It's going to be this yellow triangle on the floor. Okay, there's going to be a bit of an overlap. So that yellow triangle on the floor helps us to work things out. So this is essentially looking at it this way. So we know that when this distance is the shortest, which is the case here, because it's going to be longer as we go to the left of this point, and it's going to be longer again as we go to that point. And now when the adjacent becomes longer, we knew that if this one increases, then our tan ratio decreases, and that means the angle also, because the angle is also directly proportional to that ratio. If it decreases, the angle decreases. But if that increases, it only increases when the adjacent becomes the smallest, since the numerator is the constant. I don't know if I'm making sense, folks. So we need the adjacent to be the smallest distance possible so that we can have the greatest value there. The greatest value will give us the greatest angle. And this is the angle that we're looking for right now. Okay, maybe let's choose a different color to avoid similarities of colors. So guys, we want this angle theta, if we want to call it. So that would be the maximum angle that we need to calculate. So this is easy because we've got this side. We calculated it above. And if we've got that side, we also have that angle. We've got this angle. It was given to us as 35, this one on the ground. So if this is 35, it means we know that the angle is essentially 90 degrees, guys, but it's showing up on the other side because I can't show it on the same side. Right. So what we need now is to say, okay, we've got the angle, we've got the hypotenuse, it's a right angled triangle. So we can look for this side, because if we get that length, this is still 108 meters. So if we can get that length, the tangent of whatever this is going to give us the biggest angle possible. So this is where the trick was with this question. You had to think outside the box, I guess, and even distort the diagram in 3D to be able to see what we need to do. I guess this is essentially how we can work this out. The minimum was already given here indirectly, so we don't have to worry about that. That would be the smallest angle we can get. But now we want the greatest so that we can work out our range. Alright guys, so for B, it's a bit of a situation. So technically, we're going to work on this triangle first. This is the triangle on the ground, which is the yellow one that I showed over there. So all we need is to find that BE, okay? So we can decide and say let point E be directly, you can just say let, so that we can make it easy. Let point E be directly opposite B such that BE is perpendicular to CD. So that's the first thing, because we know once we get that distance, then we work out in this triangle to finish our business. Okay, so what I'm gonna say, guys, we know that essentially in triangle BED, this is on the horizontal plane. What do we see? We know that we're interested on this side, and of course on the ground that side is opposite angle 35, and we know that the hypotenuse side is what we know, so that is sine theta. So we can just say sine 35 degrees. It's going to be the opposite side, which is EB or BE. We said BE there, so maybe let's put it as such. BE over. Then the hypotenuse is essentially what we calculated above. BD. It was 100,7116. Right. So what are we looking for? We're looking for BE. Okay, let's get BE, because that's the distance that will give us the greatest angle of elevation from the car to the top. Okay, so we've got essentially 100,7116 times the sine of 35. So this gives us a 57. As you can see, that is the smallest distance. Can you see? Because anything else after that would force us to use our triangle rules. And we may, yes, win, but with a lot of difficulty. But I think this is fair. 57 compared to those heights, hundreds and what. I mean, those lengths, not heights, but so this is good. So this is going to be 7,658 meters. Okay, just to keep it nice and easy. So folks, to finish this business now, what are we looking for? We're looking for angle theta. Maybe we can say also, angle theta is going to be the angle of elevation, not elevation. Angle, can even that is the theta, also theta B, angle of elevation from from E to A. It helps to really set up the stuff, because now this needs a bit of planning, critical thinking, you name all of these things, problem solving. So from here we know that essentially then we know that the tangent of theta is going to be equal to the opposite side, which is 108, divided by the adjacent side, which is what we just found out, is 57,7658. So therefore theta is what we're interested in. It's going to be the arctan of 108 divided by 57,7658. Right. So let's see what is the value of theta there. So shift 10 of 108 divided by 57,7658. Okay. As we can see, guys, this gives us 61, to 2 decimal places. This is going to be 86 degrees. Okay. And we can see that that is certainly big compared to the other ones that we see, 47 and 28. And we know that this is the greatest we can get. So we can say, therefore, the range of angles of elevation is going to be such that the minimum is going to be such that, what can we say, guys? Maybe let's just say it's an element of, because the range is going to be some kind of an interval. It's an element of including the smallest is 28 degrees going to the biggest, which is 61,86 degrees. These are included. Okay. Right. This is how this problem is certainly to be solved. Okay. Or at least one can write minimum 28 to a maximum of. See, there are many ways of writing this very same thing, so you don't really have to really have a problem. Okay, you can just say angle of elevation is from a minimum of 28 degrees to a maximum of 61,86 degrees. Done. Perhaps, yeah, but nothing was said that we need to keep it to the what. So you can write a sentence here that captures all that you have done, or you just stick with the maths, guys. You see most set notation. Once you talk of a range, we include everything that's possible. So this is how, guys, I would think about it. As you can see, this part becomes a bit vague if a student doesn't understand what is going on. This part is a bit vague, whereas this one is a bit direct. This one is easy to see, but the second one needs a distortion of the diagram, because once the diagram is distorted, then we start to see better, right? Without a bit of a distortion, it becomes a bit of a problem. So again, sketches help, guys. So this is how I suppose this problem is to be solved. Yes, there can be other techniques. Well, at the end of the day, if the problem is solved, folks, that's what matters. So here we're scoring just how many marks? 6. Okay, I can think about how do we distribute these 6 marks over this piece of work that we did. Well, first and foremost, doing some things like this. Sometimes a construction statement, remember, it's like doing a proof. A construction statement sometimes may be significant because without it, there's no form or structure. Then the basis of the argument is pure guesswork. Okay, but once you put a structure, we're already showing that we have a form on which to base our work. Now, secondly, folks, to define the sign of the angle, just to know that this is it. I think this is good, and finding this value is very important. Okay, and essentially this sign, the tangent of theta, when we are looking for this angle, this is it. So 1, 2, 3, 4, 5, and of course giving the answer eventually. Essentially noticing that this becomes the minimum was actually the key to this issue right there. The other mark could easily be directed at the minimum because we know the maximum. We've already scored a mark, so it's coming up nicely. All right, guys, this could have been a very nice and tasty 14 marks for students who really sit down and look at their work with enthusiasm. But those who sit down and look at their work with a bit of anxiety, discomfort, and perhaps resentment, this would become one of the reasons for them to just feel like maths is torture. But maths is the fun in the world, because even those who claim to know it, they struggle. I also struggle, but I claim I have a bit of an understanding of at least the basic math that is necessary for someone to know if they are willing to get into the science fields. So I know a bit, but I don't know it all. But I think at a basic level, I can safely say I may not sink the ship, although I won't win every battle. Anyway, guys, I hope you enjoyed the video and you can see the element of creativity needed to handle these questions. So it can't be just some crazy blanket approach here that is taught in class. There has to be some show of, excellency in the subject by a student by being able to imagine things in different planes, because this is the idea of 3D structures. Anyway, guys, that's it from me. I will see you again next time. Keep practicing. You're going to get better.